In this particular lecture, we'll be working on a numerical regarding thermal properties of matter. Let us see that numerical right now. So here the question which is given is regarding a wire of length L0 is supplied heat to rise the temperature by T. It means that delta T is given as T. If gamma is the coefficient of volume expansion of a wire and Y is the Young's modulus of this particular wire, then the energy density stored in this particular wire, you are supposed to find it out. Let me consider that this is a wire which is given to us and the length of this wire is equal to L0. The length of the wire which is equal to L0. Whenever you supply some heat to this particular wire, then definitely we know that this wire is going to expand. And that heat is given that it is the temperature of this one is raised by T. It means that the delta T change in temperature is going to be T. Okay. Then now, if particular heat is been given, the expansion of the wire is taking place. If expansion is happening, it is nothing else but it is linear expansion is happening. So we know the formula for the linear expansion. Linear expansion is equal to, as per linear expansion, the formula is delta L is equal to L alpha delta T. Let it be my equation number 1. And this particular equation delta L is equal to L alpha delta T. We can write it as delta L over L is equal to alpha delta T. Let it be my equation number 2. What is this del L? Del L is a change in length once the heat is applied to this wire, and L is the increased length, and alpha is nothing else but L is the original length and alpha is the coefficient of linear expansion, and delta T is the raised temperature or change in temperature. And we also know that longitudinal strain is given by formula del L over L. So this del L over L is the strain. So we can write our formula as strain is equal to del L over L, and del L over L is nothing else but alpha delta T. So let this strain equal to del L over L. This be your equation number 2. Equation number 3. And since here in this particular numerical, Young's modulus of the wire has been given, we know the formula for the Young's modulus. Young's modulus is equal to Y is equal to stress over strain. It is stress over strain. And from this one we are supposed to find it out stress. Why do we are supposed to find out the stress? Why? Because we are asked to find it out energy density stored in the wire. Energy density is nothing else but it is the amount of potential energy stored in a wire due to different stresses that is acting upon the particular wire whenever it is being heated. So that is a Young's modulus is equal to stress over strain, and stress is nothing else but it is the formula for the stress becomes Young's modulus into strain. Young's modulus into strain. So this is your formula for the stress. Let it be your equation number 4. Then what is energy density? Energy density is the amount of potential energy stored in a wire due to different stresses per unit volume. So it is nothing else but it is E over V is equal to half into stress into strain. Let it be your equation number 5. Now substitute the value of stress in this equation number 5. Your equation becomes as E over V equal to 1 over 2 into Young's modulus into strain. It becomes strain whole square. Now what is strain? Strain is the longitudinal strain, that is delta L over L, that is equal to alpha delta T. So if you substitute alpha delta T, your equation now becomes as E over V is 1 over 2 into Young's modulus into alpha square delta T square. and alpha is nothing else but alpha is a coefficient of linear expansion, and in your problem gamma is given, that's a coefficient of volume expansion. Try to convert alpha in terms of gamma. We know the relationship between gamma and alpha. Gamma is equal to 3 times of alpha. So now here alpha will become as gamma over 3. Then what about delta t? Delta t is equal to t, which is given in your problem. So now we can write it as E over V is equal to 1 over 2 into Young's modulus into alpha is gamma over 3 whole square t square. Now if I expand this particular term, it becomes E over V, that is equal to 1 over 2 into Young's modulus into gamma square by 9 into t square. And this equation, if I do the multiplication of this denominator, it becomes 1 over 18 into Young's modulus into gamma square t square. And this is going to be your solution for this particular numerical. So the energy density for this particular wire, or the energy density or the potential energy stored per unit volume in this wire, is equal to 1 by 18 times of Young's modulus into square of the gamma into square of the temperature. So this is your numerical. I hope students you have understood this particular numerical. Thank you.